Section 2.7, Related Rates, page 1. So calculus is the study of rates of change. And in this section, we're going to see how derivatives, which are rates of change, fit into real world scenarios. And for us, most of the time, this is going to be based on time. And so we'll use the variable t. Now, we said we're talking about rates of change, which mean derivatives. And some of the key words let us know we're taking a derivative, as you might be asked, at what rate is something happening? How fast is something happening? How is the value increasing? How is the value decreasing? So down below it says, let L be the length of a baby chinchilla. So, right, I don't know if we're measuring it that way. Then dl dt represents the rate at which the chinchilla is growing. And in our case, the rate will be positive since the length is increasing. We're assuming if the chinchilla is growing, it's not an older person who's shrinking, right? But because it said let L, we have this L function, and we have to assume that the function is changing with time. The chinchilla is growing over time. That makes time our input. And so if we're asked to find the rate it's growing, that is a derivative. And so we can either use L prime notation where t is the input, or dl, derivative of the L function, over dt, so about the t variable. And we assumed it's positive again because it's increasing. Look at the scenario here. First bullet point, suppose that you were on your way to CSULB, and so we're going to let x represent the distance between us and CSULB. So if I take the derivative of this x function, dx, and I take the derivative about time, that is going to represent the rate at which our distance is changing. Rate of change is a derivative, and in our case, the derivative is going to be negative because the distance is shrinking. Maybe at first we are 5 miles away, and then we get a little bit closer and we're only 3 miles away, and now we're almost here and we're 1 mile away. So the values are getting smaller, so our rate of change would be negative. Yes, you can have negative derivatives. Second bullet point, suppose that we're on our way to Cal State Long Beach, same problem, but now we're gonna let y represent the distance that we have traveled. We started our house, and so far maybe we've gone 10 miles, and as we continue we will have gone 12 miles, etc. So if y is our function, then when we're asked how fast, that implies a derivative, so we would have dy, and it just says how fast we're traveling, but our speed is based on miles per hour. Per hour is time, right? Although we could be measuring meters per second. In this case, remember, our numbers keep getting bigger, so the derivative will be positive. Whenever it comes to solving a problem that's more real world like, then the best thing is to follow a certain set of procedures. For example, if ever possible, draw a picture. That can often be really helpful. Be sure to name all of your variables and what are the derivatives associated with those variables. Find some sort of equation that links all of the variables in the problem. But notice there's going to sometimes be a variable in your equation which is not given, and which is not giving a rate, and you might be asked to find the rate of something that's not in the problem, so you might have to use substitution. For example, we're going to use the Pythagorean theorem to maybe find a hypotenuse, or we're going to be given diameter but need radius for a formula. But the most important part is when we're solving these problems, we need to be sure that if we're finding some sort of rate of change, that we're going to take the derivative of both sides of the equation, but it's going to be with respect to time, unless you're told some other variable. And that means we're going to have to use implicit differentiation. Now this says via the chain rule because that's kind of the fundamental thought behind implicit differentiation, but we're going to have to just focus on using implicit differentiation. Once we have a derivative, instead of maybe even solving for dv, dt, or whatever it is, I suggest go ahead and just plug in the values that you do have right away. And this will make solving for your unknown easier. And off to the right is a set of formulas that if you don't know, you should know.